Evening.
Howdy. Thanks for coming out. The sun is out, so it's all looking good for the pre-modern world tonight. I'm Linda Kuhn. I'm Dean of the Honors College, and I'm very excited to be introducing the second of our signature seminar sneak previews. Last week we had fascists. Pretty good civil engineers in the room, right? This year we're looking at the pre-modern infrastructure of some of the great, truly great world civilizations. It's going to be awesome. And then next week, on the 19th, a week from today, we will be looking at a signature seminar called She Done It on female criminals. And these are our three for the fall. For the students in the room, you have to apply to get into one of these signature seminars. The deadline is March 29th. The application can be found on the Honors College website. Just have to write a couple of short essays. It's not onerous. But our desire is to get the architect sitting next to the civil engineer, next to the mathematician, next to the historian. You get the idea. That's who we are. We're the interdisciplinary space among all the majors. And even computer science. We want all kinds of different students in this class. So I'm introducing to you somebody I call Doc. And of course it's Kevin Hall in civil engineering, who holds the Hicks Endowed Chair in Infrastructure Engineering. That's very fancy.
Very fancy.
And that's what's so cool, because of course this class will be looking at the history of ancient infrastructure. It's kind of unusual. In fact, my colleagues abroad, and even in this country in the history of science programs, have been emailing me about this class. I got an email from Penn, History of Science, from somebody who's writing a book on the history of engineering, who wants to come down and take your class. So we're getting a lot of interesting national play on this one, because I think the ancient piece makes this a little unusual. But Professor Hall is going to give us a sneak preview of this class. And he's going to, of course, encourage everyone to take it in the room. And even if you can't, I'm sure he'll let you sit in on sections, depending on your taste in ancient civilizations. But Kevin Hall is a very well-published scholar of cement and asphalt. But of course, the Romans were great cement builders, as everyone in the room probably knows. That's why you're here, right? So there's a reason why somebody who works in the pavements would be interested. He comes from a family of great historical lineage. I'll introduce Natalie Hall, who's a historian of the late Roman Empire. So what we can hope is that there's some kind of fight that ensues over our tensions between the history of technology and the history of religion, or something crazy like that. So anyway, I'm going to go ahead and hand it over to Kevin Hall. Let's give him a big hand.
Thank you so much, Dean Kuhn. I appreciate that. Thanks for coming out today. Appreciate it very much. And we're going to kind of step through, give you a little sneak preview of the class that we're proposing to do this fall. And so I'd really like for this to be less of just a lecture and more of just let's chat for a while this afternoon and kind of see where we're going to go with this thing. I'm always open to suggestions. The class has not been set yet. A couple of things about me when I do lectures like this. A couple of things. One, if you notice the duct tape on the floor over here, this is my aside box, because when I lecture, things pop into my head and it's kind of an aside. And when I do that, I'll come over here and actually do the aside, okay? The other thing is that I always start my classes with an A. Now, if you catch me in a mistake and you point it out to me and I agree with it, then it's 1 letter grade per mistake. And if I get down to an F, I'm having a bad day, we're all going home, okay? So just feel free to try to catch me on that. So that's what we're going to do. And so just relax. And at certain times, I'm going to have you do some things, and we'll just make it a little bit interactive and go at it like that. So engineering antiquity, the idea of how did they used to do it? I really got interested in this, and Dr. Kuhn mentioned my wife, Natalie, has her PhD in early Roman, late antique, lots of different words there, and so we started going to Italy so she could research in the catacombs, and that got me to thinking, wow, there's a lot of engineering here. So I've been very fortunate to actually lead 3 study abroads to Italy with engineering students, with civil engineering students, so we can look at Roman engineering and also modern European engineering. And it's really, it got me to thinking, you know, we really ought to have a class about this. And so that's kind of the genesis of where we went. A few little facts. How does what they used to do relate to what we do now? A few little facts here. One, there are about 4 million miles of pavements in the United States today. Okay? 4 million miles of pavement. Now, those pavements are built either out of asphalt or concrete for the most part, right? So how much? Well, golly, every year in the United States, there's about 350 million tons of asphalt produced in the United States every year. Think about that number. 350 million tons each year. There's also about 260 million cubic yards of concrete produced each year in the United States that go into pavements. Okay? And so that's lots and lots of stuff. Now, concrete and asphalt don't just happen by mistake. It actually has to be designed, believe it or not. So what goes into concrete and asphalt? Well, rocks. We like to say a better word than just rocks. We call them aggregate. Sounds a lot fancier, yes, but they are just rocks. And so a lot of rocks. And if it's asphalt, then you bind the rocks together with the black oily sticky stuff that we call binder. If it's concrete, well, you mix a little sand with it, you mix a little cement with it, and you mix a little water with it. And this is what creates 260 million cubic yards of concrete, 350 million tons of asphalt. Now, how do you design those things? How do you know how they go together? Because the recipe is really, really important. A little bit too much of this, a little bit too less of that, and things don't work very well. So the way we design these things are relative volumes of material. It's a certain volume of rock and a certain volume of cement, and a certain volume of water. And so one of the big questions we have today is, how in the world do you measure the volume of an oddly shaped rock? How in the world do you do that? Well, golly, it's kind of interesting. Richard, in book number 9, he shares a really funny and probably familiar story. It seems that the king of Syracuse, the newly appointed king of Syracuse, wanted to dedicate a golden crown to the gods and put it in one of the temples. And so he weighed out very carefully an amount of gold and gave it to a craftsman and said, create a crown that I can dedicate to the gods and put into the temple. And so at the appointed time, the crown came back. It looked great. It weighed the right amount. But he started hearing whispers that, hey, this contractor may be a little shady. Substituted a little silver into that gold and then kept the gold for himself. And so the king of Syracuse was like, how can I figure out whether or not this is true? How can I figure out if he ripped me off? So he went to a friend, really smart guy, and he says, can you figure this out for me? Well, the friend studied it, couldn't come up with a real good solution, so decided to take a bath. And so as he was lowering himself into the bath water, he noticed, when I get into the bath, the water runs over the sides. Interesting. And when I get out of the bath, the water goes down. I wonder if that could be the secret. And in fact, he got so excited about that solution, he jumped up out of the bath and ran home without putting anything on, shouting, "Eureka, Eureka!" which means I have found it, I have found it. And sure enough, he was able to measure how much water came out of the bathtub when he put that amount of gold in versus how much water came out of the bathtub when he put that amount of silver in, and was able to figure out that the crown the king had was actually an amalgam of gold and silver. Kind of an interesting little story here. This happened in the 4th century BCE. So today, getting back to our 260 million cubic yards of concrete, 350 million tons of asphalt each year, how do we measure the rocks? Well, we weigh them. It's easy to weigh, right? We weigh them, but then we put them underwater and weigh them again. And the difference between those two weights is the amount of water that was displaced by those rocks. Grasshopper. It's also the volume of the rocks, of the water displaced by those rocks. And so, in hundreds of laboratories every day in the United States, this kind of test is run, and it's based on a principle developed by a naked, wet Greek guy running down the road, Archimedes. We use Archimedes' principle every day in civil engineering, in the materials area. So then, what they did 2,300 years ago resonates with us today to build the infrastructure that we have. And so, kind of a cool little story there, right? And you know, that's one of the things about this class. And in fact, I was telling Dr. Kuhn earlier, one of the hardest things about this class is going to be, what do we include? What do we not include? Because there's only so much time. And there's all kinds of cool stories like that that we can look at. Infrastructure, what they used to do, but it has such resonance with what we do today. And I think we can learn from it. So, from that, let's talk a few terms before we get too far into it. Let's talk about the idea of science and technology and things like that. Now, this is going to be a history thing, right? And let me say up front, because I see some in the room here, there are some historians here. I do not claim to be a historian, okay? That's my hand to God. But I'm going to come over here to my aside for a minute. I'm a history buff. And as an aside, how do you become a buff? What are the qualifications for a buff? I don't know, that's just an aside, but how do you become a buff? Anyway, I'm going to claim to be a buff. So, science. When you look at, we've called this engineering antiquity, and I'm really going to focus a lot on engineering, but can we really separate the engineering from the science, from the technology, from the math? Well, science, yeah, investigation of the natural world, that's one definition. There are many, versus maybe technology, which is really a practical mastery of that natural world. In fact, some historians that I've read will separate these things into, when you look, one of the dangers is putting our definitions today on the way they would have looked at it back then. And science back then, yes, I'm trying to understand the natural world. Technology was really, the root of that is really a craft. It's the idea of craftsmen, of creating something. It may or may not have anything to do with science, but it had to do with a craft, a worker, somebody who's trying to master a process, yeah? And so there's some science, there's some technology. Of course, engineering, this is a book definition of it, application of science and math, so that we're looking at, and the big phrase, the reason I like this particular definition is we make it useful to people. Because at the heart of engineering is that we're trying to create things and processes and products that ultimately help people. In fact, one of the things that we talk about in engineering when we talk about ethics, the canon of ethics for professional engineers, canon number 1 says, we shall hold paramount the safety, health, and welfare of the public. We work for the public. So engineering takes the craft of technology. It takes the knowledge of science, and it applies it so that it's useful to people. And so when we start looking at the history of engineering, if we start looking at how they engineered antiquity, we're looking at how did the engineers of the early centuries BCE, early century CE, how did they help the societies in which they work? Also, obviously, we have math. So I don't know, Dr. Goodman-Strauss, is this a decent definition of mathematics?
Sounds good.
Works for you, huh? Okay, very good. The abstract science of number, quantity, and space, studied in its own right, or is it applied to other disciplines such as engineering? So it's the tools that we use, yes? The tools that we use in order to accomplish the engineering that we want to do. Now, this class, it would be so easy in a class like this to just tell the cool stories, right? It would be so easy to just focus on this development in technology and this development in technology, and isn't it cool how they invented the flying buttress, and isn't it cool how they invented an aqueduct, and isn't it cool how in Mesoamerica they built pyramids, even though we all are familiar with the pyramids across the ocean. And so this class could become that, but it's so much more than that, because at the heart of it, why did you engineer? You engineered to help society. So we really need to address the context that the engineering occurred in. Yeah? Now, one particular book that I've picked up and looked at, James McClellan and Harold Dorn in Science and Technology and World History, there's different ways you can break this up. One of the ways that they broke it up is they looked at something called the Babylonian model. Somewhere 3500 BCE up to about 500 BCE. And it's the idea that science, math, engineering, technology, those things really were patronized by the state because the state needed tools to help supply and govern people. So it was really applied technology so that, and the pursuit of knowledge, so that you could help govern fledgling civilizations. And so one of the things that we really have to do when we study the history of engineering, the history of science, the history of technology, is we have to put it in the right context. That the early scientists, the early engineer, the early technologists were working for the good of that society in that particular context. And so the Babylonian model, state patronage, when cities first developed, when civilizations first developed in perhaps the Neo-Babylonian part of the world there, the idea here is it was to help govern. All right, so a second one, maybe, and these authors call it the Hellenic model. Think Aristotle, think ancient Greece, the idea of pursuing knowledge for knowledge's sake. And if this doesn't resonate, I want you to think about this. In today's world, do you agree with this statement that in many cases we have converted college education to job training? Do you agree with that statement? Okay, this is interactive. You can nod, you can shake.
Yes. It depends.
Oh, it depends. I have an engineer in the crowd. We always teach our civil engineering students, when asked a direct question, the answer is always, it depends. Why? Because the consulting fees continue to come in. Yeah? That's a little cynical. But I want you to think about this. Knowledge in this first model being used to help govern versus knowledge for knowledge's sake. And so in parts of ancient Greece, and in fact some of the landmark things, Archimedes, Pythagoras, Euclid, with the Euclidean geometry, right? Knowledge for knowledge's sake. Sure, could it be used by somebody else? Yes, but is that why it's created? Not necessarily. It was the pure pursuit of knowledge. Versus then perhaps what these authors call a Hellenistic model, and I'll say something about that in a minute, where you kind of combine the two. That yes, the state patronized the pursuit of knowledge for knowledge's sake, but it'd be great if we could use that knowledge then to help people, to help. This class is not Western technology focused. This is going to be a global class. We will be looking at China. We will be looking at the Western Hemisphere, Central South America. We'll be looking at the Middle East. We'll be looking at Sub-Saharan Africa. So yes, so don't get thrown by this. This is this particular set of authors' idea to help us arrange our minds. When we start looking at technology, we look at the context in which it was created. And I think that's going to be a real key in this class, is looking at the context in which it was created. And so that's one way to arrange it. Not the only way, but it is a way to arrange it. Yeah? Okay, so I want you to do this. I'm going to give you about 23 seconds. Okay, 23 seconds. I want you to find somebody around you and tell me what is a basic need of society. Ready? 23 seconds. Go.
Water seems to be popular.
And I should tell you, if your answer doesn't cut it, you will be chopped. Okay, we got it? Basic societal needs. Okay, so let me go right here, this pair right here. What do you got?
Sanitation.
Sanitation, okay? All right, what about you guys?
Food and shelter.
Food, shelter. See, this is where I have to be really careful with my letter grades, because if you give me something I can't spell, it's going to be bad. What about up there? Water. What kind of water? Clean water. Drinkable water. Okay? Water. What about you guys?
We got like child care.
Child care. Okay? Okay? What about you guys? Yes?
You said shelter.
Shelter? Got it. Okay? Dr. Dennis. What is it?
Health care.
Health care. Child care. Health care. All right. Who? Way up in the top.
Got all our food.
You got all our yours. What about up right here, young man?
Well, I said food, and then someone said something more profound as self-actualization.
Wow.
Wow. Okay.
Sign that up.
That would be in the limit model.
Self-actualization. I'm not sure I can engineer that, but we'll try. Yes. Law. Okay. Okay. Yeah.
We said water and transportation.
Water and transportation. Okay. We have water already. Okay. So, anybody else got a burning one that we didn't list?
Defense.
Defense.
Boundaries.
Boundaries. Okay. My pen's running out, but that's okay. I forgot to look and see if this pen was good, but that's all right. Yes.
Education.
Education. I thought, what didn't the song? Oh, that's an aside. Didn't the song say we don't need no education? But anyway, that's an old song. Okay. Education. So that's a pretty good list. It's a pretty good list. Civilization, ancient civilization. What were their basic needs? What are our basic needs? Now, a good list. So I was kind of hoping that you guys would kind of hit some of the same words I did. So yes, water supply, absolutely. And so nice little photo of one of the remains of one of the aqueducts of Rome, yes? Which, to be honest, I'm not so sure we could replicate today, given the grades and how straight and go, don't get me started, right? All right, or do get me started. Water supply, somebody said, who said water supply? A+, all right, here we go. Food supply, a secure food supply, yes? I think every society needs a food supply. Sanitation, yes. Roman public toilets there. Looks inviting, does it not? Yeah. So, really fascinating article just came out recently about maybe Roman public toilets weren't quite so sanitary. But anyway, yeah. So we've got those. Structures, yeah. You know, this is actually my photo from one of our study abroad trips, and I asked my students, so look around you. Obviously, this is the Pantheon, completed what, 1st century BC, or CE, a little bit later than that. Still standing, yeah? 1900 years later. And I was like, look around the modern buildings, the ones that there are in Rome. 1900 years from now, do you think they'll still be standing? In fact, my bet is the Pantheon will still be there. Maybe the modern buildings, not so much. Yeah. But structures, a basic human need, societal need. Defense, somebody mentioned defense. And so, whether that's a wall or some other thing, we're not going to go there. Okay? But it is a basic societal need. Transportation, yeah. That happens to be a street in Pompeii. But, yeah, transportation. Getting our food supply to us efficiently. Getting goods and materials from point A, getting people from point A to point B, yeah? So you guys are doing really well. Medical care, certainly. A little thing from Egypt there, looking at some of the medical care things. There were some other things I could have chosen, but they probably weren't real suitable for mixed company on that one. Communication, I don't know if we put communication there, but communication in all forms, right? The written word, the stuff to write the word on. And if we go forward in history, we're not really going to get up into the Middle Ages in this class, but certainly the invention of movable type, and you could go on and on and on, all the way to today with those ubiquitous little boxes that we carry in our hands for communication. Or has it actually reduced our ability to communicate? That's a different question. Trade. I don't know. Nobody mentioned trade. Few civilizations, few societies. Well, there were some, but are they totally self-sustaining? But as civilization grew, trade. And so that means what? Transportation. That means communication and other things. This particular shot is a relic from Mesoamerica, which had a very flourishing trade system in Mesoamerica. And so those are just some of the basic society. We didn't mention some of them, but golly, we got y'all did pretty well. And so congratulations. It's you know what I was thinking. So good for you. All right, now kind of interesting. When you look at the list, and this is a good list, it basically matched what I was. Basic societal needs then, but I would guess that you were thinking when I asked the question, those are basic societal needs now, are they not? And so one of the elements of this class that got me to thinking about it is, when you get right down to it, basic societal needs really haven't changed in 4,000 societies needed then. Somehow, they met those needs. We meet most of those needs today. I wonder how those solutions, technological and otherwise, actually compare. And that got me to thinking, that would make a great class. In fact, some of the questions we could ask, I think, would be, how did ancient societies meet their basic societal needs? And certainly that's going to be the largest part of this class. Looking around the world, how did Central and South America obtain clean drinking water? How did Sub-Saharan Africa do clean drinking water? How did the Middle East? How did China? How did that happen in those various societies? You know, we love to point to things like the Romans and their aqueducts, but you know what? People need water all over the world. And yet we see different ways of doing it. We see the invention of water screws to lift water from one elevation to the other, and that is not necessarily Greek and Roman. That was done in multiple societies. And so that's the kind of thing that we need. So how did they do that? Now, the corollary question to that is, it's one thing to say, hey, that's cool. That's really cool how they did that. But really what we want to know is, what can we learn from those solutions? What can we learn today from the way that they solved their problems? Because if you think about it, we live in a time, we have all the advantages. We have all the tools. Right? I mean, goodness gracious, I sat through 4 semesters to learn the tools to be able to do the calculations for the technology and engineering that I was being taught how to do. What did his society do before the invention of zero? Right? When was that?
I'm not sure.
It's what, the 6th or 7th century, I think. Yeah? What did societies do before zero was invented? What tools did they have? And yet, they met the basic societal needs just like we do. Yeah. And so, kind of cool. What can we learn from their solutions? What can we learn from their thought processes on how to go about doing this? For example, consider a Roman road. I'm a transportation person. I do pavement. Somebody's got to, right? All right, so a Roman road, it's a marvel, honestly, of engineering. When the Romans built roads, they built them straight, they built them wide, they built them sloped on the sides for good drainage, They built them clear. In fact, going through wooded areas, they would actually clear the land 100 paces on either side of the road. Now, that was a safety thing so that people couldn't attack them when they were on the road, but they made big right-of-ways for their roads, and they cut them straight. They sloped them for drainage. They made them wide because they needed to move not only goods from place to place, they needed to move their army from place to place quickly and efficiently. So the Roman road, a marvel of engineering. What can we learn from that? Is there a way, is there an example of us building roads wide and straight and sloped for drainage and with plenty of right-of-ways? Oh, I know. How about the Dwight D. Eisenhower National System of Interstate and Defense Highways, what you know as the Interstates? It is a direct reflection of the way the Romans built their roads. When President Eisenhower said in the height of the Cold War, we need a way to move troops and goods from one end of this country to the other and get them to places that they need to be, we need a system of highways to do that. But it can't be following the deer path up the mountains. They've got to be straight, they've got to be wide, they've got to be really well built because they have to be efficient. And what was the model? The model was the Roman road. So how did they meet their societal need versus how do we meet our societal need? It's a direct correlation. And so one of the things we need to look at is, what can we learn from the way ancient societies met their needs? So far, so good? So far, so good. What is another key question here? Were there consequences stemming from their solutions? As a technology person, as an engineer, there's really nothing we can't do. Now, that's not very good English, but I'll say it anyway. In fact, I have a colleague, Gary Prinz. He's one of our younger professors. He teaches structural engineering, and one of the things he tells his students is, you are a superhero. I mean, Marvel should make a movie about you because you can do things no one else can do. Yeah? I don't think his students believe him, but hey, he tells them that anyway. And so, but if there's nothing that we cannot do, are there consequences to that? What can we learn from the consequences? What can we learn from the consequences? Let's ask it a different way. Is all technological advancement desirable? It's an open question. In fact, one of the things that I want to entertain in this class is changing the question that engineers typically ask, not can we do it, but perhaps should we do it? Do you guys like going to New Orleans? People like, or as they would say down there, New Orleans, right? Yeah? So, the hubris of the civil engineer. Here's a city. It is 10 miles from the ocean. It is 10 feet below sea level. We can protect it because we're civil engineers. And every time we say something like that, nature says, hold up here. I'll show you. So superstorm comes in, our pumps are overwhelmed, the levee breaks, the ninth ward. Consequences. Not can we do it, but should we do it? Can we learn from history the consequences of technology? We have an example right here in Northwest Arkansas, do we not? Because there was permitted, and in case you haven't noticed this, we do actually have a national river in the state of Arkansas. It is called the Buffalo River. If you've never canoed the Buffalo River, shame on you. You should canoe the Buffalo River. It is one of the most gorgeous places in the state of Arkansas. Hog Farm was built on a tributary of the Buffalo. It was permitted because there was an engineered plan for the waste lagoons. We are engineers, we can do it. But now there seems to be a load of nutrients in the river and some algae blooms in the river. Can it be traced back to the waste? Well, it depends on who you talk to. But again, it boils down to not can we, but should we? Should we? Is there an ancient example of this? Well, I lauded the Romans for their roads, right? So let's use another Roman example here. How about the catapult? Okay? Catapult's a pretty cool, I mean, goodness gracious, it's very cool. Let's just be honest. In fact, I have been trying to get the powers that be in the College of Engineering. I've not asked our Associate Dean, Dr. Dennis, about this, but I would like for one of our design groups to actually build a catapult and start throwing watermelons at the business school. I just, why not? Just launch them right over physical plant, just try to land them right in front of Willard Walker Hall. I think we could do it. But maybe we should ask the question, should we do it? Anyway, I guess that was an aside. I should have been standing right here. The Roman catapult. Marvelous engineering, very effective at what it did. And certainly to meet a basic societal need, oh, wait a minute, it's up here somewhere. Yes! Defense. Yes. So the Roman catapult could absolutely be for defense. But you know what? It's a better weapon for conquest. It's a better weapon for conquest. There's a dark side to the development of the technology. In fact, depending on whether you think Josephus was true or not, a Jewish historian writing in the 1st century CE was writing about the sack of Jerusalem by the Romans. He was amply supplied with quick fires, catapults, and stone throwers, with which not only he beat off his assailants, but also killed many of the worshipers. From the missiles from the engines flew over with such force that they reached the altar in the sanctuary, lighting upon priests and sacrificers. The dead bodies of natives and aliens, of priests and laity, were mingled in a mass, and the blood of all manner of corpses formed pools in the courts of God. What misery to equal that most wretched city thou hast suffered at the hands of the Romans. Military technology is particularly vulnerable to this, right? We create technology to defend ourselves, but that technology can also be used in an offensive manner. Colonization, right? Conquering. So there is a downside to technology that we really should consider. So in this class, not only were we looking at, yes, how did society meet their needs? And there's some really cool technology doing that. But is there a consequence to that technology? Now, you might be sitting there saying, wait a minute, it's not the technology's fault. Catapults don't kill people, people kill people, right? Right. So we have to be a little bit careful, don't we? In fact, we probably ought to be thinking about a balance here. We ought to be thinking about the idea of projection versus absolution. Now, what do I mean by these words? So when we're looking at ancient technologies, and we're considering the questions of, are they good, are they bad, are they neutral, we have to be careful not to project our system, our culture, our system of values, our ways of thinking onto ancient peoples, a different culture, a different time. That's why it's important that we study the technology in its own context of when it was developed, and not try to project our value systems on an ancient society that may not have shared that same value system, and declare them evil when in fact that's just our opinion. Yeah? Absolution. But the other side of that is, do we absolve the technologist, the engineer, the scientist of all responsibility of the technology that they create? Do we just give them a pass? You created the technology. Are you not responsible for that technology? I don't know. It's a question that needs to be asked. Yes? So do we absolve all responsibility? Do we project our own value system on them? There's a balance there somewhere. So when we look at ancient technology, when we look at ancient solutions, let's be very clear-eyed about it. Let's be very honest about the very good that it did, that society, and meeting those basic societal needs. But let's also be very clear about how that technology could have and maybe did get misused. Yeah? And certainly that is a discussion that is going to be very important to us as we move forward. Look at the technologies that are being developed today. There's such great potential for the human condition, but there's also such great potential for harm. Yeah? And so I think it's really good if we look back and look at ancient technology in those same lights. And that's one of the things that we hope to do. Okay, and now a word. What is the word? The word is, anybody want to guess? The word is why. Now, let me do a little aside. Any Star Trek fans in the audience? Yeah? Old or new? So, let me get to it aside. In The Wrath of Khan, okay? One of the Federation ships lands on a planet where Khan and his people have been exiled, and he wants to know why they're there, because they were exiled there. Nobody should have been visiting them. And he takes Chekhov, and he raises him in the air, and he wants to know why, and he goes, why? That's my question. Why? Why study this? Why do this? Why consider ancient technology? Well, we have some goals for the class. First thing, it's cool. It's just cool. I mean, goodness gracious, it's really cool. And so that's our first goal for the class, is it's cool. Yeah? All right, so, but we're going to examine technical solutions to societal needs. We've made the case, maybe you're convinced, maybe you're not, I don't know, but we've made the case that basic societal needs then, basic societal needs now are very, very similar, if not exactly the same. What were their solutions? How can we use their solutions? But we need to consider those solutions in the societal context in which they exist. What is the impact? You know, here's another aside for you non-engineers, so I'll step in my box. One of the things that we are asked to do as engineers in education is when we teach design, we are supposed to teach our engineering students the impact of that design on society. Now, I will tell you this. We have, and part of this is in our accreditation system and what they want us to do. And we have one of the nation's experts in engineering accreditation, and Dr. Dennis here, and he will tell you, I think, that this idea of societal impact of engineering solutions is one of the hardest things to teach engineering students. And so, and it's one of the hardest things to assess whether engineering students even get it or not. So that's why in this class, that's going to be a major focus. Put the technology into the context of the society in which it was created and forward. What is the impact of that technology? We're going to learn from our historic solutions, and we're going to try to apply those for today. I'm especially interested in thought processes because, again, we go back to this idea in terms of mathematical modeling, in terms of computer modeling, in terms of virtual reality, and all of the incredible tools that we have today, yet ancient societies met the same needs without those tools. Sometimes I think they were much better engineers than we are. Now, let's be fair. A building today, it's cheaper, it's faster. Cheaper, faster, cheaper, faster. It may have taken 25 years to build something in the Roman Empire, but it's still there. It takes us 25 months to build it. Will it be there 2,000 years from now? I don't know. So let's not go too far, but at the same time, what can we learn from their thought process? Yeah? And then ask the right questions when considering advances in technology. Because I want to take this from a history class, but I want to make the application to the future. And so when you consider technologies today and the things that are coming out, then what are the right questions to ask? You know, we've seen reports from China about literally genetic engineering in the womb. Oof. What are the right questions to ask? What are the questions to ask? And I think a class like this, by looking back and looking at the lessons of the past, we can start to formulate questions for the future in technology, I think. So that's kind of what the class goal is all about. Now, that's what I've got. I wanted to leave plenty of time for discussion and questions and things like that. Thank you for your attention. I appreciate that very much. What questions do you have? What questions do you have? Yes?
Not a question, Kevin, but we found engineers in antiquity found out about things through trial and error.
Yes.
They built something, it fell down, they made it better.
They made it again.
we do the same thing today with all these new tools we have.
Absolutely.
We don't discover the errors until a catastrophe happens, and then we can create a mathematical model to describe the failure. We didn't know it was going to happen until it happened. Or we wouldn't have built it that way.
And that's a great point. You know, I've always loved the old Calvin and Hobbes strip, where Calvin asked his dad, how do they figure out the load limit for bridges? And his dad says, well, they just drive heavier and heavier trucks over until the bridge fails, and then they rebuild the bridge. It's exactly your point. That is a great point. Thanks, Norm. Questions, comments, suggestions for the kinds of things we ought to include in the class. I'm open to suggestions. The class is not set yet. So, yes?
Will you look at engineering, religion, and antiquity?
The engineering of religion?
Why not?
Okay, I hadn't thought about that. I was thinking infrastructure, but certainly we can probably take a look
I
at
was just
that.
thinking that'd be a cool global trek.
Yes, it would be. And in fact, I will tell you that the way that we're planning on arranging the class, it's 1 day a week. It's a 3-hour seminar, 1 day a week. And each week is going to be a topic like water supply or food or shelter / structures. So we'll take a topic each week and we will look around the world at how different societies met that same need. And so that's what we're going to look at. So that's the way we're going to do it. But the engineering of religion.
Well, I think they would consider, I can't name an ancient culture that wouldn't think that that was a necessary thing to live.
Yes, absolutely. In fact, yeah, I think you're exactly right, because when you look at ancient cultures, it seemed like everybody had a deity, right, of some type. And so what was the engineering around that?
I would say for the Romans, that is infrastructure, since that was so much part of their state
Yes,
ideology.
absolutely. That's a great point. Yes?
Going off of what Dean Kuhn is talking about, I'm also thinking about, I studied Spanish literature and I read all the conquests, anything written, but I'm thinking about how religion influenced what could and couldn't happen, right? And so thinking about sanitation, indigenous communities in Mesoamerica would shower daily because it's hot, but when the Spaniards arrived, they would tell them not to shower daily because religion, something or other, they shouldn't do that.
I need to talk with you more about that. That is a new story for me. So that's great. Thank you for that. Yeah. Huh. Interesting. Okay.
Well,
And
that's
I'm
why the
thinking,
religion angle would be good, because
Yeah.
it's, I know engineers are very logical, and sometimes religion forces you out of that nice structured existence.
yes, it can. Okay. Very nice. Thoughts, questions, comments? Nothing? Yes.
Could you comment on the whole concept of lost technologies?
Lost technology.
Yeah, then and now.
Right, it's something I didn't really put into this presentation, but so let's think about the most famous example, right? So you look at the incredible architecture and engineering of the Greek and Romans, okay? Then we won't say she's taught me, not the fall of Rome, we'll say the transition, the decline of Rome. No decline. What is my good word?
Transformation.
The transformation of the Roman Empire. So, for about 1,000 years, it didn't seem like architecture, engineering, and otherwise in Western Europe, there didn't seem to be a lot of advancement. Is that an easy way to say it? Yeah. Okay. Why? And then, picking up in the 14th, 15th, 16th centuries, all of a sudden, whoop, we started going again. What happened? Why in the world could we not do what used to be done? Yeah? And so I think it's a fascinating thing. And in fact, and I'm really glad you brought that up, because one of the things that's been swirling around my head, and I need to do a lot more research on it, is what other technologies have been lost? We have stories of Greek fire. Yeah? Is it actually napalm? It's similar. But it was lost for a time, yeah? So I think it's a fascinating topic. So not only the solutions, but the solutions that we have some historic record of that now we simply don't know. anymore. I think it's a great topic. Thank you. That's a great topic, and I think we'll have to dedicate at least 1 week to that. The lost technologies. Yes. All right. See, these are great. This is great. This is helping me. What else? What else? Yes.
So you talked about how catapults, they could be used for defense, but they're much better for, conquest. And then you also talked about how we're going to be looking in the future and how comparing today's society with like ancient technology. Would we also be looking at like modern weapons like nukes?
Well, okay, so,
that could be used
exactly. And so the ethical dilemma is still there, right? I mean, you read about the 1930s and the 1940s, and even in the Manhattan Project, some of the scientists were very conflicted about what they were doing and the ethic of what they were doing. What is the famous quote from J. Robert Oppenheimer? "I have become death, the destroyer of worlds," when the Trinity bomb went off in Alamogordo. Yeah? And so yes, I think that's going to have to be part of it. This idea of can we versus should we, that's going to have comes into this class is we're not going to shy away from the hard discussions because I think it deserves coverage and it deserves some attention. I will say we're not going to get political with it because we're going to approach this from a technological standpoint as much as we can. I get it. But so I think you're exactly right. By looking back and looking at what we can learn from history, let's take that forward into how can we apply that today, that same kind of thinking. Yeah, so.
I guess on that note, I guess there were a number of well-known ancient ecological disasters
Yes.
as well, or sometimes fostered by the technology that they could exploit the land and overexploit it.
Absolutely. Well, and so if you didn't hear this, the comment down here, so one of the things that we have to look at is those consequences of technology, ecological disasters. And so that is absolutely going to be part of this. When we start looking at consequences, then certainly we're going to have to look at, the overproduction in agriculture, slashing forests, things like that. Absolutely. Yeah, so that's absolutely going to have to be part of it. Because it's so relevant to today too, right? Absolutely, yeah. So, any other thoughts? Yes.
So you spoke a little bit on how we have structures today that are still standing from antiquity, and how structures today maybe won't be lasting as long.
Who knows?
But should they be lasting as long as?
That's a great question. Should they be here 2,000 years from now? I mean, I don't know. Dr. Dennis was right. A lot of trial and error back then. Of course, we do have. They were really smart. I mean, stairs just a minute. Can you follow? Yeah. So, when I stand in the Pantheon, especially in the middle, kind of look up at the oculus, yeah, and I'm looking at this coffered concrete ceiling that has no columns, and I'm thinking, could we build one of these today? We probably could, but the specification manual for that would probably be this thick. Yeah? Goodness gracious. So, it's a great question. What we're building today, can it last? Should it last? Should we be looking at, and this is something that engineers are really grappling with right now. Somebody mentioned earlier the idea of sustainability. We also use the term resiliency as well in engineering. And so rather than I'm going to build this and it's going to last 1,000 years, is it I'm going to build this so that it can be renewable, yeah, with just a little bit of routine maintenance and rehabilitation so that, yes, it would last, but not in its original construction. So is that a better way to go? It's a great question. And it's a question we probably ought to think about, yeah? Well, I hope so. I'm glad you're excited about it. Even if it's just me and you, doggone it, we're going to have a good time. We'll have a good time. Yeah, absolutely. Anything else? Anything else? Okay, well, thank you very much. I hope to see you next fall, okay? So